Now we're going to be moving into what we call an inverse function. Okay, so take a look at question number 49. It's going to look hard the first couple questions just because it's something new. However, after you guys practice, you guys are going to notice things are going to be different. Inverse functions are not hard. Honestly, they're not hard. It just takes practice. The beginning, it will be difficult because it's something new, but it is not hard. Okay, so each of my functions, to begin with, they're going to be called something like g of x, f of x, h of x, or something, right? I'm going to use at the very beginning g of x, f of x, or anything that I choose. Sometimes it's h of x. Now, that g of x, what I'm going to do, I'm going to ask you guys to do is change that. The first thing that you guys see here, in this case, g of x, change it to a y. So rewrite everything, but instead of g of x, I'm going to write y. So let's see. Let me write this as y equals -4 plus the fifth root of 16x over 2. Okay? So instead of g of x, f of x, h of x, anything that you guys see there at the very beginning, just call it as a y. Now, on the right side of my equal sign, I see another letter. In this case, is an x. Sometimes it's another letter. It's not always x. Sometimes it could be n, anything. All right, now what I'm going to do, the y in that other letter, they're going to switch. So y and x are going to switch, okay? So let me call this x equals -4 plus the fifth root of 16y all over 2. So again, notice how my x and my y, they switch places. That's basically what happened. Okay, so now what I'm going to do is solve for y. Okay, so first thing, I see there's a fraction, so let me multiply both sides by 2. The reason why I want to get rid of fractions. So that's going to give me 2x. It's equal to -4 plus the fifth root of 16y. Remember, I'm trying to get y by itself. I'm solving for y. All right, so this -4, I see a -4 that has nothing to do with the y. So I'm going to move it. -4, let me move it to the other side as a +4. So I have the 2x plus 4. It's equal to the fifth root of 16y. For space purpose, let me move this up here. Let me move this over here. All right, so I see 2x plus 4. You learn how to factor back in algebra 1. I see I can divide both by 2, so that gives me inside my parentheses x plus 2. Notice 2x plus 4, I divided each by 2, so I put my 2 on the outside, and this is equal to the fifth root of 16y. Okay. Remember what's the opposite of a root? Exponent. So I'm going to do everything to the fifth power. Exponents and roots, they undo each other. Remember how a couple of days ago we learned exponent divided by root? That becomes, in this case, 1. So that's how I'm going to undo exponents. You guys learned that adding and subtracting undo each other. Multiplying and dividing, they undo each other. So same thing, roots or radicals and exponents, they undo each other. So, okay, so I have 2 to the fifth times x plus 2 to the fifth. It's equal to 16y. Notice how my exponent and my root, they undid each other. Now, 2 to the fifth, let me erase that. We can do better, right? 2 to the fifth, isn't that 32? So let me call that 32. Okay, so remember I'm solving for y. I want the y by itself. I have 16y. So let me divide both sides by 16. So I'm gonna get y by itself. Now, on the left side, 32 divided by 16. Isn't that 2? Then I have x plus 2 to the 5th. So a little recap. Instead of g of x, I call it y. Then my y and my x switch places and solve for y. Now, the way I'm going to answer this, because I'm not quite done yet, I solve for y. Remember how at the beginning this thing was called g of x? So the inverse, we're going to say g inverse of x. So the g to the -1 basically means g inverse. And my answer is going to be 2, and then inside parentheses, x plus 2 to the 5th. That's how I'm going to answer this. All right, let's take a look at another example. The way I'm going to start this, I'm going to say y is equal to 2 over negative x plus 2, right? The f of x, I'm going to call it y. It's a little bit easier. Then the y in the letter, so y and x. Sometimes it's x, sometimes it's n, sometimes something else. So y and x are going to switch places. So let me call this x equals 2 over negative y plus 2. And my goal is solve for y. All right, so let me get rid of fractions. I'm going to multiply top and bottom by y, negative y plus 2. So these cancel out. So that gives me negative y plus 2 times x is equal to 2, right? I got rid of fractions. Okay. I'm not going to distribute the x. It's going to get ugly. I want y by itself. So let me divide both sides by x. I guess I have to go with fractions, but at least I don't have y at the bottom. So that gives me negative y plus 2 is equal to 2 over x. Okay, I think I almost see that y by itself. There's this plus 2. Let me move it over as a minus 2. So I have negative y. It's equal to 2 over x minus 2. I'm almost there. Get the y by itself. The way I'm going to undo a negative y, I'm just going to multiply everything by -1. Basically, switch the signs. So y equals negative 2 over x plus 2. Notice I switched my signs. So the way I'm going to write this will be f inverse of x, because it was f of x to begin with, equals negative 2 over x plus 2. Nice. Let's take a look at number 51. To begin with, let me call this y equals negative 2 over n minus 1. Y and the letter are going to switch places. So I'm going to call this n equals negative 2 over y minus 1. Got to solve for y. Okay, so what I'm going to do, let me multiply both sides by y minus 1. I always choose whatever's at the bottom, because that way they cancel out. And that gives me y minus 1 times n equals a negative 2. I want y by itself, so let me divide both sides by n. So that gives me y minus 1. It's equal to a negative 2 over n. Notice how I brought the negative to the front. I want that y by itself. So this minus 1, just going to bring it to the other side as a plus 1, right? Opposite signs. So that gives me that y equals negative 2 over n plus 1. So the way I'm going to answer this, I'm going to say g inverse of n is equal to negative 2 over n plus 1. Nice. Let's take a look at question number 52. To begin with, let me write this as y equals x minus 1 to the third plus 1. X and y are going to switch places. So I'm going to call this x equals y minus 1 to the third plus 1. Okay, got to solve for y. Don't have fractions, so that's good. What I'm going to do though, this plus 1, let me move it to the left side as a minus 1. So I have x minus 1, it's equal to y minus 1 to the third. I wish I knew something that got rid of exponents. I know adding and subtracting, they undo each other. Multiplying and dividing, they undo each other. So exponents. I'm going to do roots. So I'm going to do the cube root of x minus 1. It's equal to y minus 1. I'm going to do radicals. Roots undo exponents. I'm doing cube root because it was to the third power. Let me rewrite this, what I have here. Cube root of x minus 1 is equal to y minus 1. I just wrote what I have, okay? I just copy it down. Y by itself, I need to get y by itself. So this minus 1, let me move it over here as a plus 1, has nothing to do with the root. So don't put it inside the root. I'm going to say cube root of x minus 1 plus 1, it's equal to y. Notice I kept the plus 1 outside. That's it. I solved for y. So the way I'm going to answer this, I'm going to say h inverse of x. It was h of x to begin with, so the inverse I'm going to call h inverse of x equals the cube root of x minus 1 and then plus 1. Nice. Let's take a look at number 53. Let me write this as y equals the cube root of x minus 2 and then outside a minus 2. X and y are going to switch places, so let me write this as x equals the cube root of y minus 2 and then a minus 2. Got to solve for y. Now there's a minus 2 on the outside. I'm going to move it to the left as a plus 2. So that gives me x plus 2 is equal to the cube root of y minus 2. Wish I knew how to get rid of radicals. Remember, multiplying, dividing are opposite. Adding, subtracting are opposite. Exponents and radicals are opposite. So let me just write this as x plus 2 to the third is equal to y minus 2. Notice how I got rid of the radical using exponents. All right, I see a minus 2 there. So I'm going to move it to the left side. Leave it outside of the parentheses though. I have x plus 2 to the third plus 2 is equal to y. See how my minus 2 and moved it as a plus 2? Have y by itself. That's it. So I'm going to write this as h inverse of x is equal to x plus 2 to the third plus 2. Beautiful. All right, let's take a look at number 54. To begin with, let me write this as y. Instead of h of x, I'm going to write it as a y. Y equals 2 minus x to the third. And then y in the variable, so y and x, they're going to switch places. So let me call this x equals 2 minus y to the third. And then I got to get y by itself. This positive 2 has nothing to do with y. It's positive 2 on the right side, so I'll move it to the left side as a minus 2. So that gives me x minus 2, it's equal to negative y to the third. Okay, so the y, two things. It has a negative and it has an exponent. The exponent has nothing to do with the negative. So let me undo the negative first. The way I'm going to do this, I'm going to switch the signs of everything. So let me write this as negative x plus 2 is equal to y to the third. Notice I switched the signs on everything. Okay, so my last step, I have to get y by itself. Okay, it's y to the third. So the way I'm going to undo an exponent, I'm going to do it with a radical. So cube root. Inside of my radical, let me write negative x plus 2. That's it. So the way I'm going to answer this will be h inverse of x. It's equal to the cube root of a negative x plus 2.